we should wait any further. Let's move forward. Can you hear me? Let's move ahead. So then it says at point P, the receiver detects a maximum amplitude of the stationary wave. That means, say, this is point P. That's the line across that receiver. That's point P. And at point P, maximum amplitude. That means we expect an NT node at point P. The devices move slowly from point P along the line XY, and the receiver detects a series of minimum and maximum amplitudes. The first time a minimum amplitude is detected is when the device is at Q. So that means this, let's say, is Q. So the maximum amplitude was at P and the minimum amplitude is at Q, right? That means we expect an NT node at P and node at Q. Okay. Then they say determine the distance. So basically, in the last page, we just figured out wavelength that was 0.048 meters, right? So we can see this represents quarter of a wave, and that would be the distance between PQ, right? So 0.048 divided by 4 is going to be the distance, which would be 0.012. Then it says the intensity of the microwaves emitted by the device is increased. So they're increasing intensity. Okay. Frequency is unchanged. The device is moved slowly along the XY from point Q until the next maximum. That means whatever this device was, this is moving towards here. And then we have R and we have maximum amplitude at R again. Okay. So state and explain whether the distance QR, this distance is comparable to this distance. Okay, so basically distance should be same. Reason is, let me write it first. So distance should be same. Reason is distance was a function of wavelength, right? So wavelength is not changed. That's constant. They clearly mentioned frequency is constant. And since it is a microwave, so speed is constant. So there is no possibility that wavelength could be changed, right? So intensity cannot alter the distance for node to NT node in a stationary wave. That's important. ठीक है, ये बात ज़हन में रखनी है. What else? So we have to find out the wavelength of the sound. We have CRO that is set to 5.0 exponent minus 4. Okay. So if we start here, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1. So almost 5 point something, right? So यहाँ से if we go from here to here, so digitally I counted 5.2. So 5.2 से I think 5.8 तक के आसपास होगा जो भी कुछ होगा. So if you count more clearly, so for each box we have 5.0 exponent minus 4. So time it with 5 point, let's say 8, yeah, 5.2, yeah, 5.4, whatever. That is going to give you time, right? So we can use lambda is equals to V into T. So V is 330 into T would be 5.0 exponent minus 4 into 5.8. So lambda comes out to be 0.96 meters. Okay, the loudspeaker now moves in a straight line while emitting the same sound of constant frequency. Okay, period of the trace increases continuously. Okay, period of the trace. That means this trace is like, kind of like this, and then it goes like this. So it is increasing constantly. So determine the motion. So what we can identify is if period is increasing continuously, that means this loudspeaker, wherever it was, so that loudspeaker is basically moving away from the, speaker source. Why? Because if source is moving, loudspeaker is moving towards the source, then we should expect lesser time period. So it says time period is increasing. So motion of the loudspeaker is moving away from the source or detector at an increasing speed. ठीक है भाई? That's what should happen. So do we get this? Let's see. आगे चलते हैं. What else? So we have a wire, we have to find out potential difference, current given here, resistance. So we can just use V is equals to IR, 0.85 into 3.3 exponent minus 3. So that would be 2.8 exponent minus 3. Show that cross-sectional area. Okay, so R equals to rho L over A. So we have to find out A, that would be rho L over R. Rho is going to be 1.8 exponent minus 8. That's given. Length is 0.24 over resistance is 3.3 exponent minus 3. So 1.3 exponent minus 6 is the area. Number density. So number density is number of charges per unit volume. So number of charges basically is given in the question 2.6 exponent 22, and we have volume that would be area into length. So 2.6 exponent 22, area is 1.3 exponent minus 6 into length would be 0.24. So we get 8.3 exponent 28. Then they said drift speed. So we can use this equation. I is equals to NAVQ. So V would be equals to I over NAQ. So we have current that's 0.85. Number density is 8.3 exponent 28. Area was 1.3 exponent minus 6 and charge is fixed, quantized. So we have V, that's 4.9 into 10 with power 5 meters per second. And then what else? So we have a different copper wire Q, same volume. So volume of P is the same as volume of Q. So volume was area into length. So that's important. Then it says radius R1 at end X is the same. Okay. State and explain how the resistance of the wire. So basically, if we compare this wire resistance, so resistance is rho L over A, right? So we can clearly see here we have the same radius. That means same area. So at the start, resistance of P should be equals to resistance of Q. But as we move on, what happens? Resistance should increase because area is decreasing, right? Also, length would be more. So, sorry, length would be more. So resistance would be more. Why length would be more? Because volume constant है, ठीक है? और एरिया जो है वो कम हो रहा है, तो लेंथ को ज्यादा ही होना चाहिए ना, तो उसको किसी ने टेपर कर दिया मार मार के, तो सो वी कैन से resistance of Q is greater than resistance of P, as length of Q is more than length of P, and area of Q at R2 is less than area of P at R2. Got it? Average drift speed. So drift speed should increase, simple increase होना चाहिए, क्योंकि R1 पे और R2 पे देखेंगे तो करंट सेम होगा, करंट सेम होगा तो रेजिस्टेंस चेंज हो रही होगी, रेजिस्टेंस चेंज हो रही होगी तो ड्रिफ्ट स्पीड बढ़ रही होगी, वोल्टेज बढ़ रहा होगा. दैट इज इट. ये तो बड़ा आराम से आप कर लोगे, आई थिंक, राइट? So this should be 222 plus 4. That should be 226. दैट इज 88 एंड 2 यहाँ पे है, तो यहाँ कितना होना चाहिए? 86 स्पीड ऑफ द न्यूक्लियस आफ्टर डिके। क्या हो रहा है भाई? आइसोलेटेड स्टेशनरी डिक्यूज इनटू आर द अल्फा पार्टिकल इज दिस। अच्छा, अल्फा पार्टिकल की स्पीड होना चाहिए। तो वी हैव टू फाइंड आउट द स्पीड ऑफ न्यूक्लियस आउट, ठीक है। So this is basically to momentum conservation. This basically determined to be R and alpha particle. तो अल्फा पार्टिकल की उन्होंने स्पीड दे दी है 1.5 एक्सपोनेंट 7 इंटू 4 टाइम्स कर लेते हैं एटॉमिक मास यूनिट। और आर के लिए हम कर लेते हैं काइंड ऑफ ट्रिपल टू, इसका मास ले लेते हैं इंटू यू प्लस वी, सॉरी प्लस नहीं है, मास इंटू वेलोसिटी, सो दैट वुड बी वी। सो वी आप फिगर आउट कर लो, यू कैंसिल आउट हो जाएगा। सो वी वुड बी 1.5 एक्सपोनेंट 7 इंटू 4 डिवाइडेड बाई ट्रिपल टू। सो दिस कम्स आउट टू बी 2.7 exponent 5 meters per second. Three quantities that are conserved during the decay. So we can see charge is conserved, we can see momentum is conserved, we can see mass is conserved. बहुत सारी चीजें कंजर्व है, कोई मसला ही नहीं है, राइट? सो आई सपोज दिस इज इट। ठीक है, चलो, डू वी गेट दिस? चलो, लेट्स एंड, टेक केयर, लॉफ।